Telephone banking office, calls come in at a rate of 1.8 per minute. That's a clue that it's a Poisson, it's happening at a constant rate. And there was 1 mark for stating the distribution you're using as Poisson with lambda as 1.8. Part A, show the probability of no calls in the next minute. We've already mentioned the probability x is 0 for a Poisson is e to the minus lambda. So yep, we get what they say on the paper. So you don't get the mark here for that. You have to show the calculation e to the minus 1.8 to get that mark. Part B, exactly 9 calls in the next 9 minutes. Well, we know it's a rate of 1.8 for 1 minute. So for 9 minutes, the rate is 1.8 times by 9. So now we're dealing with a lambda of 16.2. And we want exactly 9. So it's a case of using the formula for Poisson, putting the numbers in, and you get an answer out of 0.0195. So for part B, 1 mark for the calculation, 1 mark for the answer. Part C, no calls in exactly 4 of the next 7 minutes. You often get last parts of Poisson questions like this. They are now taking you out of the restricted world of Poisson into the world of binomial, yes. So we've got n is 7. We've got 7 minutes. P is the probability of getting no calls in a minute, which is already worked out up here. So for the last part, we've got a binomial. N is 7, P is 0.1653. That statement there is worth a mark. And we want exactly 4 calls. So we want probability of getting 4. So there's your binomial formula. N choose R, P to the R, 1 minus P to the N minus R, a mark for the correct calculation, and then a mark for the answer. So there are 7 marks available altogether on this question. It was 1 at the top for the distribution, 1 for the calculation for part A, 1 for a calculation and 1 for an answer, and then down here, 1 for a distribution, 1 for a calculation, and 1 mark for an answer.